So for the people who are not able to make it to class, if for some reason something ever happens and you are not able to make it to class, do know that I'm always going to be recording these, and I will put a link on YouTube that I will send out through Remind, as well as put on that actual Google Doc weekly plan so that you can go back and look at it. But if for some reason you are not able to make it to class and you watch that YouTube link, I still need to interact with you at some point, and that's how you're going to get credit for participating for the week in the class. So since I am combining the two classes, because that way I only have to do this once instead of twice, it does take me a minute to, one, get everybody in, and two, check people off. So I've done the best I can, but let me actually, because there's some people whose title of thing I can't quite figure out who you are. So let me say who I have not checked off. And if you are present, then in the chat window, you can send a private message just to me and let me know that you are here. So I don't see Robin on this list, unless you are the question mark or one of the other computer names I don't recognize. I don't see Erica. I don't see Patrick. I don't see Chanel. I don't see Trenton. I don't see Malachi. I don't see Kamaya. I don't see Charlie. I don't see Millie. So that's from third period. Again, if any of you were here, please type in to the chat window and say, hey, this is me. And then from fifth period, I don't see Demonte. I don't see Arundhati. I don't see Noel. There's Michaela, just jumped in. I don't see Covenant. I don't see Kamal, and I don't see Anaya. Okay, so those are the people I don't see at the moment, and we'll figure it out from there. So for the most part, to keep this to 45 minutes, what we're going to do is, this is much more of a very quick, me-focused time, and then office hours are more focused on, if you have particular questions, you need me to slow down and go over things, that's what that time is for. Okay, so okay. All right, so now let's start going through. All right, so I see Chanel's here now. And who is my question mark again? Whoever the question mark is, tell me who you are. I don't know who you are, but I see Covenant and Chanel now. All right, Erica, got it. Okay. Yay. Sweet. Okay. Hi, Janae. Nice to see you. Welcome back from New Orleans. All right. Okay, so here's what we're doing. This is going to last at least 5 weeks. That's what we know. We know that we are out through April 24th. That is a full 5 weeks. That we will finish up the packet that we've been working in, the Intro to Types of Bonds. We'll finish that up this week. And we'll start the packet that I gave you on that Friday before we left. And hopefully those handful of people who I didn't see on Friday, you were able to go get it. If not, I can give it to you electronically so that you have it. But we'll start going through that packet, and I haven't sat down to plan it all out, but we might finish up that packet before this 5 weeks is over with, in which case our next unit is actually chemical reactions. And chemical reactions are fun. I will also say that I went up to the school and I brought home a bunch of materials, and so I've got a giant tub of basically chemicals and equipment behind me, so if we do start chemical reactions, I can still do demonstrations. I can do all sorts of stuff that I would do if we were in class behind me, which is fun. So we'll run through that. I'm going to try and keep things as normal as possible. So the kinds of assignments we still normally have, we will still have. We'll still have ed puzzles. We'll still have columns most of the time. So the things that will kind of adjust is how to figure out assessments. And, you know, I'll work that out as we get to it. But otherwise, I want to stick with only having class on Wednesday, Friday. This class will not meet on Mondays. Okay, so Monday for me is that time where you can take care of all of the other work you need. You can do your ed puzzle, you can do your column, like whatever. We're only going to have these 45-minute classes on Wednesdays and Fridays, 11 to 11:45. That's it. That's all I'm expecting. I do have those office hours available for anybody who needs to have questions answered, which I can go over in more detail later. I do not yet know when Advisory 3 will end. As soon as I find out, I will tell you, because I know there's a large handful of people who are a little concerned about the status of their grade. And that is almost exclusively due to a missed quiz or lab. And we can go over how you're going to take care of that. It's not that your grade isn't going to change, because it is, but we're going to have to do some one-on-one time for those people who need to take a quiz or who need to get me actual like physical lab information and stuff like that. So we can fix those grades. So I want you to just, you know, calm down. And for some people who were eligible for a quiz retake, we can also still arrange quiz retakes without any problem. So that's not going to be an issue. So I don't want people freaking out over their grade. We can handle that. So today I just wanted to review electronegativity, because that deals with our bonding. For people who were here on Friday, you know, we tried to do some of the polarity stuff with that polar bear comic, and I know some people took some pictures of it, some people didn't. So I want to review that really fast, and then just give you a couple of reminders, let you know what we're doing on Friday, and then that'll be it. So, all right, I think I went over all of that. Yes. The main thing I want to say is we need to make sure that you're communicating. So for those people who were saying that you were still having problems with Remind, I'll go back through this afternoon and try and individually go through each account and see if Reminds or if replies are turned on. And if they're not and I can't turn it on, then I'll send you a separate email message. But if you are not used to checking your email, you need to become somebody who checks your email, because this is how we are going to stay in any sort of communication. So between email and Remind, we need to make sure that that is working. I will send out that weekly plan that I sent out over the weekend. I'll send out one of those once a week that has everything for the week. And that is basically the document that you need to live off of for a week. It's got everything for me. All right, so in the packet itself, I didn't put in the full reading here because that doesn't make much sense, but this is the page right before the polar bears and penguins on your packet. It's titled at the top, Periodic Trends in Electronegativity, and it has that image. So what I've done is that's the image from the middle of the reading, and on the right-hand side there, those are the questions that are on the right-hand side of the document. On Friday, we didn't do this reading. We just kind of jumped right into class. So I just wanted to touch base really fast and make sure that we review this before we get going. So from prior memory or from this image itself, which element has the highest electronegativity? And now somebody can unmute themselves and tell us what the answer is.
I want to do it.
Okay.
I think it's F.
It's F, yes. And what element is F?
It's F.
What element is F?
I don't know.
It's fluorine.
Fluorine, yes.
I know Thank you, whoever did that.
Okay. Okay. So fluorine has the highest electronegativity. And again, that is up here, right here. And again, these noble gases don't have any, so they're not going to be involved in our bonding. We kind of ignore them for most of the rest of the year. Okay, so do metals or non-metals have higher electronegativities?
Non-metals, right?
Yes, yes, thank you, Ryan.
Yay!
Okay, so non-metals have the higher electronegativities. Those are these guys up on the right-hand side. And remember, your metals all the way over here on the left, very, very small electronegativities. So we did all that before. And then this question is worded kind of strange, but it says, how is electron placement related to electronegativity? And by electron placement, I mean, think of electronegativity again is our attraction. So electron placement is, do you want the electrons to be close or far away if we want to have a high electronegativity? You want them close or far away?
Close, right?
Close, yes.
Not close. Okay, yeah.
Okay, so you want your electrons close. So that means we want small atoms, and our small atoms are also our nonmetals. Okay, so how is electron placement related to electronegativity? You want smaller atoms because you want the electrons close. Next, why does fluorine have the strongest pull on electrons? Well, that should be related to what we just said.
Because it's the closest to having a full outer shell?
No.
Oh, bro.
That's
Can you
what.
repeat the question real quick?
So why does fluorine have the strongest pull on electrons? And it's going to be related to what we just said.
Non-metal.
Isn't it because?
It is a nonmetal.
Isn't it because like the nucleus has more traction because there's not as many things around it?
Yes. Okay. So fluorine, remember, fluorine is really small. It's not the smallest element, but it is really, really small. It only has basically its electron configuration ends on level 2. So it's not very big. It doesn't have hardly anything between the nucleus and those valence electrons. So there's no real barrier there. There is nothing blocking. The electrons in fluorine are really, really close to the nucleus. So therefore, fluorine has a really strong pull on the electrons because it is so close to the nucleus. Okay, nice background. All right.
Backman, are we supposed to be writing this down?
I mean, that's up to you, but I would think so.
Oh, okay. Sorry.
I mean,
Wait, Miss Baskin. So for how is electron placement related to electron negativity? I wasn't listening. Can you repeat it?
How's does somebody want to answer that?
Y'all better answer.
What was the question? What was the question?
Nobody
The
knows.
closer the
Smaller
electrons
atoms,
are together, more electronegativity, right?
Electrons to be
The
close.
closer they're together, and what he
All right. I got it. Thank y'all.
Okay, cool. All right, back to muting. Okay, so, all right, so I'm switching over to my iPad so that we can do the polar bear and penguin review.
Is she
Do we
dropping
need
off?
to write this anywhere?
What?
Do we need to write this down anywhere?
Yeah, are we
So-
supposed to do it on a specific packet or just like general notes?
No, this is still in the intro to types of bonding.
Let me go get
One of the little warm-ups, this one? The
I
little
left
one?
my binder at
Yeah, so starting on the next page, you should see in your packet, find this picture.
Oh, we did that, Miss Baskin.
Yeah, but not everybody was in class and we kind of rushed through it and we really only talked about the first handful of questions.
Yeah, we stopped at, I think, 3.
Right. So that's why I wanted to go back to this for this class. Okay, Dakara.
Ms. Baskin, what's the title of the packet?
This is what?
What's the title of the packet?
Intro to types of bonds. It's the very end of that packet.
Wait, is this the packet that like we've been working on, or the one that you handed us
The
before?
one we've been working on. We're not going to start the one that I handed you until next week. Because we didn't have a good ending to this packet. Like, we were all thinking about what's going to happen in Corona and all this other stuff. So I know our brains were all over the place. So I just wanted to make sure this week that we just kind of tied all this together. Because when we jump into naming and formula writing next week, if we can't identify something as ionic or covalent, then you can't start. So we have to make sure we're clear on ionic and covalent and what's going on with electrons first, which is why we're finishing this up this week.
What if you left your binder at school?
She recorded.
Yeah.
Y'all be
Uh-huh.
oh shoot.
She's
I'll send you-
recorded, not recorded.
You know what the fuck I said. Don't.
It doesn't record us, right?
No,
Oh,
it's
God.
recording my screen.
Okay, yeah.
Okay. All right, so let me start going through this. So for those people who were here, yes, you saw this. But for those people who were not, I'm going to go through, this is just the pictures of the comic that's broken down. We're just going to kind of go through the questions. So you don't have the comic, you have the questions. So I'm showing you the comic as we go, and that will make it easier to kind of be able to answer things. So I'm going to kind of go in order. So this was for the warm up, and it was like, draw the Lewis structure for HCl. And we did the Lewis structure means valence. It means dots. Draw the dots. So we said hydrogen has 1 dot because it's got 1 valence electron. It's in group 1. And we said chlorine is in group 17. So it has 7 dots, right? So 1, 2, 3, 4, 5, 6, 7. Now, when I did this in class, I was like, well, actually, if we look at it this way, and we're used to always putting the dots on top, but if I put it that way, what this shows me is that these 2 things, those are my shared electrons, because this is a covalent bond. Because if my penguin here is hydrogen and my chlorine here is a polar bear, those are both non-metals. So I'm making a covalent bond here. So those are shared electrons. That's what we're talking about. And if that's the case, well, then in this diagram, these actual ice cream scoops for everything in here, those are my shared electrons. And if I'm looking at this, this is not equal sharing. And the way I kind of typically think of this is, you know, a Kit Kat bar. When you buy a Kit Kat, it comes with the 4 bars. And if you've got 4 things, there's multiple ways to share 4 items with somebody.
Ms. Baskin,
Yeah.
is this like an analogy for electrons? I'm sorry, I wasn't paying attention.
Yes, ma'am.
All right, thank you.
Okay. So if I've got a Kit Kat, it's got 4 pieces. I can, if I really love somebody, split it exactly in half. I keep 2, I give somebody else 2. That's equal sharing. Most people don't do that. If somebody asked you, can I have some? If you only give them 1 of your 4 pieces and you keep 3, you are still sharing. You're absolutely still sharing, but you're not sharing equally anymore, and that's okay. So actually, the large majority of covalent bonding is still sharing, but it's not sharing equally. It's giving 1 piece of your Kit Kat instead of 3, and you know what? That's how I do it. I'm not going to give you all of my Kit Kat. I'm sorry. Okay. Question, we good? All right, so moving on. Yeah, wrong way. Doop. There we go. Okay, so the first couple of questions, we're all looking at the front page of this comic. And so our polar molecule, right? Polar molecule just means something with a difference in electrical charge, okay? So if you have a difference in electrical charge, then you are going to be polar. That's what we're talking about. And you see this symbol over here. This symbol is what we use to show polarity. And you should notice that you've got a positive end, right? This is my positive end, which means this is my negative end. So,
Sebastian?
yeah.
I don't see that there are polarity. I'm sorry. I don't see that packet.
Yeah, this was the comic that you didn't get to keep.
Oh, okay. Sorry.
Yeah, that's why I'm going through this. I've got the comic. This is what we're doing. Okay. All right. So electronegativity. Our general thing for electronegativity is our attraction for bonded electrons. So we've basically just answered questions 1 and 2, right? A polar molecule is something that has a difference in electrical charge, and electronegativity is talking about the ability of an atom to attract bonded electrons. Right, so that's all review. And in this instance, between hydrogen and chlorine, who's more electronegative there? Anybody? Who's more electronegative between hydrogen and chlorine?
Hydrogen.
Chlorine.
Who's closer to fluorine?
What?
Chlorine.
You didn't say fluor. You know
Yeah,
what?
that was good.
Okay. All right. So I know that chlorine is more electronegative because it's closer to fluorine. That's how I know that. Okay.
I got a
So,
question.
yes,
What question we on?
that was just questions 1 and 2.
Okay.
Yeah. So I know people who were in class, you're beyond this point already. I know. Okay. All right. So the image at the bottom of the comic was this guy, and it's like these dudes floating on an iceberg. And in this instance, what type of element do the polar bears represent? Are they metals or non-metals?
Non-metals.
These are your non-metals, right?
Non-metals.
So these are your non-metals. And that means your penguins here, these are your metals. And if you should notice that the iceberg that they're on is sitting here, it's shaped like the periodic table. And what this image is showing, right? This is question number 3. What this image is showing is that my bigger non-metal polar bears are more electronegative than my tiny little penguin metals, okay? So all that this image is showing for number 3, it's just trying to get you to understand that your non-metals are more electronegative, and that's being represented by a larger animal, literally. So that's all number 3 is trying to get at, right?
Please stop. Please stop. Let me write this down, please.
Okay, right.
Let it down, please.
I hope you all are feeling great this morning. It's a great day. Nice time to be alive.
It's back.
Basket.
That's I love you.
Okay. Hi, Rain. Giggly self.
Rain, what is so funny?
Basket.
What are we supposed to be writing?
This is somebody wanted me to stop before I moved on. This was answer to number 3.
Miss Baskin.
Miss Baskin, I didn't get 1 or 2.
Who didn't get 1 or 2?
DK.
Well,
Who said my name?
No, man.
I have a question.
Me too.
The one in red is answer number 1. The green is the answer to number 2. All right.
For the warm-up thing?
What?
For the warm-up thing or for down here?
We're down there.
Oh, okay. Thank you.
And don't forget, I'm recording all of this, so if you miss anything, you can watch the recording later and get those files in, or get those answers in. Okay, so moving on to question 4.
Wait, I got a question.
Okay, sorry, Dakar. All right, sorry, Jaden.
Oh, so non-metals have a higher electron negativity?
Yes.
Okay.
Okay. So the whole thing about making a bond is taking 2 elements, and when you take those 2 elements and put them together, what kind of bond you get is going to be dependent on what their electronegativities are, okay? So this is what we're talking about. And depending on what their electronegativities are, we can end up with multiple different types of bonds. So right now, this image is showing that I've got an element with a tiny electronegativity, my penguin, paired with an element with a large electronegativity, my polar bear, and this is giving me something unequal. But if I have 2 polar bears, are they equal or are they unequal?
Equal.
These guys are equal, all right? So if I've got equal strength here, these guys are equal. They're the same. Nobody is winning this fight, okay? So when I've got 2 polar bears or 2 penguins, this is showing that I have an equal electronegativity. I don't think I spelled that right. That's all right. Equal electronegativity or a very small difference.
Is that number 4?
Man.
All right. So again, make sure you guys are keeping yourselves muted. Okay, so that's question number 4. All right, that's all that was trying to show. Question 5 says, what 3 types of bonds are represented in this comic book? Okay, so I'm moving on to the next page. Okay, so we've got 3 different things we can have. We can be nonpolar covalent, polar covalent, and ionic. So those are your 3 different types. So for question number 5, I would go ahead and write those, right? And I would write them on top of each other. So I would write like nonpolar covalent, give yourself some space, polar covalent, give yourself some space, and ionic. And over the next couple of pages, I'm going to go over each one of those. So you're staying on question 5 as I go through these comics. So basically, up at this point, we learned that ionic is a metal and a nonmetal, and we're talking about transfer, and covalent is 2 nonmetals, and we're talking about sharing. What I'm saying is that we can break covalent down into 2 subcategories. It can be nonpolar or it can be polar. And the difference between nonpolar and polar is just the amount of sharing. So we'll start with the nonpolar covalent. And if I look here,
what question is this?
I said we're staying on question 5.
Okay.
So I go through several slides all on number 5. So for nonpolar covalent, you should notice that I've got a polar bear and a polar bear, or I've got a penguin and a penguin. Those are the same thing, because for nonpolar covalent, these are equal sharing, right? I have a small difference in electronegativity. And for the most part, these are between identical atoms, right? So here's my examples. Right? Two hydrogens together, well, they're obviously equal electronegativities, all right? Or two nitrogens, or two oxygens, or two chlorines, two of any of those, two fluorines, all of those would be a non-polar covalent. There's not actually that many of these types of things. The other thing that you're going to see is carbon and hydrogen also are nonpolar covalent because their electronegativity values are almost identical. Okay, so that's the nonpolar covalent. Not very many compounds are nonpolar covalent. So the next type, and again, we're still on question 5, the next type is the polar covalent. Note here that I'm pairing a penguin with a polar bear, so I have a difference in electronegativity. All right. It's not a huge difference, right? The penguin's still able to hold on to the ice cream. This is still sharing, but this is what we would call unequal sharing. What ends up happening is the element closer to fluorine becomes partially negative. Now, if it became fully negative, it would be an ionic compound, but it doesn't. It's partially negative. It's strong. It's not quite strong enough to completely pull that apart. And this is where you get things like HCl, HF, H2O, right? Water, very, very polar, okay? Unequal sharing, but it's still covalent because you will notice that hydrogen, chlorine, fluorine, and oxygen, those are all still non-metals. We're not talking about anything ionic yet. That's on this next slide, the last part of question 5. If I'm fully ionic, right? The difference here, I'm fully ionic. What happened to my ice cream? There is no sharing here. Okay? The more electronegative nonmetal just took the metal's electrons. All right? Just snatched the ice cream and ran off. That's what we're talking about. So that's when you have an ionic. So you end up with a full positive and a full negative charge. My full positive is my cation, and my full negative is my anion, right? So you end up with our full charges. That's what's ended up happening there. And you will notice that is when you get a metal and a non-metal, all right? So this is a metal and a non-metal. Okay, so once you get all of that written down, now if you turn the page, we can quickly answer some of the questions 6, 7, and 8. Yeah.
I'm sorry, I missed non-polar covalent.
The non-polar, it's equal, they're equal electronegativities and equal sharing.
Okay, thank you.
Yep. Okay, so when you turn the page to question 6, question 6 is actually asking us, what is this? Why are there 4 scoops there? And it's
because they're sharing.
They're sharing how many?
4. 3. Wait, no, 4.
Yes, 4. All right, so we've got 4 scoops of ice cream there. And I know I've done this in class before, but what that looks like is you've got oxygen, because we did this in your notes, right? That you've got 6 from one oxygen and another 6 from another oxygen, and that you end up with those 4 there, that's what that is. We're gonna spend more time next week starting to talk about that. So I'm not expecting you to be able to draw that right now. I'm just showing you that's what that is. So that's question 6. So then for 7, if we go forward, okay, well then look at all those scoops. What does that represent?
Triple
6, because that is a triple bond. Yes.
6.
All right. So we have a triple bond, and we've got, yes, 6 shared electrons. All right. And we'll practice more of that drawing
It's a
next
triple
week.
bond or a double?
It's a triple bond. Because
Number 6.
bonds come in pairs. So if you have 2, it's a single. Add another pair, 4 would be a double. Add another pair, 6, so it's 2, 4, 6, single, double, triple. And there's nothing over a triple bond. There is no such thing as a quadruple bond.
Triple bond for number 6, right?
No, for number 7. 6 was
Oh,
just
wait, so number 6 is, oh, okay.
Yeah, 6 is double, 7 is triple.
Okay.
Okay.
Yes. There. Triple bond.
Okay, so if we see this, I see those 2 nitrogens here and that sharing. If I'm talking about 2 nitrogens, those clearly have the same electronegativity. So this is a non-polar thing, right? And you can see that it's even, it looks even. But if I look over here and I've got my hydrogen and my chlorine, this is polar, because this does not look even. I can see that the chlorine is pulling more. And that's all we mean by a polar, right? It's literally just unequal sharing. That's the only thing you really need to make sure you understand.
Is this the answer to number 8?
No, 8. Now let's talk about 8.
What'd you say?
I said, now let's talk about 8.
Okay.
Okay. So if I look at this poor little penguin, what element is penguin here in this image?
C.
He is carbon. And each polar bear is the oxygen. So if I look, which of those two elements is closer to fluorine, carbon or oxygen?
Oxygen.
Oxygen. All right, so if oxygen is closer to fluorine, that means the oxygen, all right, oxygen is more electronegative, which makes sense because the oxygen is doing the pulling here, right? The oxygens, the polar bears, are pulling away from the penguin. That's all this is showing. All right, so this is showing that my more electronegative elements can be on the outside. So there I've got my polar bears on the outside pulling away from the penguin. But then in the next image, all right, so for question 10, now I'm looking at water. And here I've got H, 2 H's and an O. So here the polar bear is representing which element?
Oxygen.
Oxygen. And my penguins are which elements?
Hydrogen.
Hydrogens. So here, my more electronegative element is actually in the middle, pulling away from these little guys. So both of these molecules are 3 elements in a row, but it just totally matters as to which direction the pulling is kind of going. So here, the polar bear is dragging those little penguins in water, and it is why you get this weird little shape with water. I know before in previous classes and in previous times of this class,
Just slow down.
we've talked about the Mickey Mouse shape of water, and this is why it's Mickey Mouse shaped, right?
Miss Baskin, is that for 9?
No, this is 9 and 10, right?
What?
9 and 10. Or sorry, 8 and 10, whatever.
Say.
8 and 9 are over there.
Wait.
8 and 9 are just about that drawing. Like that's not even that important.
So we haven't done 10 yet, right?
10 is talking about the water. What's happening to the penguins in the water?
Confusion.
I don't know, Miss Baskin.
water. I don't see no
What is going on?
What is going on?
That's water.
Miss Baskin.
what?
Miss Baskin, did you even mind repeating 9, please?
Hey, kid.
Okay, hold on. 8 and 9 are just having you look at this diagram of carbon dioxide and see that carbon's in the middle, oxygens are on the outside, that oxygen is more electronegative, so therefore that the oxygens are pulling away, right? The oxygens are literally pulling that poor little penguin, and if they were any stronger, they would literally pluck that penguin's arms off and walk away with the ice cream, okay? But if I look at the next image, here, my oxygen is in the middle. My hydrogens, my little penguins, well, they're weak. They're not doing the same thing as what was happening in the CO2. Here, my hydrogens are just barely holding on and they are getting dragged by the oxygen. So that instead, you get this strong, straight line with CO2 because you've got a tug of war with the carbon dioxide. But in the water molecule, the polar bear, that oxygen is just dragging the hydrogens behind. And since it's just dragging the hydrogens behind, you get this slightly different shape. That's it. It doesn't matter if you get exact answers everywhere. I'm just trying to make sure that you kind of get the overall gist. I'm not asking you, I'm never going to ask you incredibly specific questions about this. It's more like, do you understand that there is a difference between a polar and a nonpolar, equal and unequal sharing? That's really it. Okay.
Asking.
Yeah.
For 9.
So the left.
Sammy, I'm talking. For 9 and 10, you can say that 10 is non-polar.
No, 10 is polar, very polar.
Okay, 10 is polar, and then 9 is non-polar, and that's something you can say for it.
Yeah, that's fine. Okay, the remaining questions on this page don't actually really matter. they don't really get at anything that's any more important. So I'm going to switch back then. Because we are pretty much at the end of class. So for people who owe me stuff, if you look in Aspen and you owe me either like a classwork grade or you owe me a lab, that is physical written work that I need to see to be able to give you a grade. And if that's the case, because some people are missing actual labs, you're going to need to send me pictures of stuff. And if you need to, you can stay on the line and do that. Otherwise, I'm going to try and stick with everything being electronic for this class to make it easier to get work turned in, and so that you don't have to deal with that.
You should get Google Classroom.
I mean,
no, we can't. No.
Google Classroom is so easy. All you can do is submit
but
the
I'm
work.
Also trying not to
No, Martina, be quiet. Go on mute.
On the card. Don't.
I'm also trying not to introduce new things, so we just stick with the way things are. So your new assignment is video 27 on Edpuzzle. You do not have a new column this week, okay? There is no new column this week. Yes. because we slowed down just a little bit to make sure that everybody gets caught up. Next week, there will be a new comm. Lastly, you have only 2 classes, but you have lots of different options for office hours. So if I went too fast for you today and you have questions, come see me during office hours. If you need to take or retake a quiz, come see me during office hours, okay? If you, just anything, come see me during office hours. On Friday, we're gonna start off, I'm gonna use the breakout room feature, and I'm gonna put you guys in small groups to do a quizzes for practice. And then I'm gonna give you, instead of doing an actual quiz on this packet, you're gonna do this sorting activity on a virtual worksheet, and that's gonna end up being your grade. We're also going to fill out the unit overview, and I'm realizing that I did not tell you guys to bring it home, so I'm going to send out that file in case you need it if you want to fill out, because we will have finished about half of the unit overview, and that's it. So as I said, I will post this up to YouTube later for the handful of people who missed it, or if you jumped in the class or your connection was not good and you got broken up. But unless you have any questions, you are free to leave.
I'll never leave you.
Bye, y'all.
I'm the best friend. I love you, girl.
Hi, Miss Best.
Y'all ugly as shit.
That's the whole problem.
Hi, Miss Baskin.
Bye.
Bye.